We're trying to decide what it is that makes a triangle congruent to another triangle. And to start this lesson off, we have a biconditional statement which uses this phrase, if and only if. And this particular biconditional says two triangles are congruent if and only if corresponding pairs of sides and corresponding pairs of angles are congruent. Let's take a look at example 1 and decide, are these triangles congruent? If you take a look at the corresponding sides, I have a 1 meter side there and I have a 1 meter side here. I have a 1.7 meter leg side there, and I also have a 1.7 there, and I'm drawing different shapes over these different sizes. That's a 2 meter side and a 2 meter side. So right now I know that there are 3 pairs of corresponding sides that are congruent. And so it says two triangles are congruent if and only if corresponding pairs of sides and corresponding pairs of angles. Well, let's look at the angles. I have a 30-degree angle here. That matches a 30-degree angle there. I have a 60-degree angle here and a 60-degree angle here. And I have a little right angle symbol, which means that that's 90 degrees, and this is also 90. So the answer is yes, these triangles are congruent. And the reason is that they have all pairs of corresponding angles and all pair of corresponding sides are all congruent. If we take a look at this pair of triangles in example B, you'll notice that we don't have any angles given to us, so I'm not really sure what we're going to do about that yet. But let's take a look at what the sides are that we have. I know that I see a 12.1 centimeter side. That matches up with this 12.1 centimeter side, and that's good. But I notice that this 8.5 is not the same as this 8.4, and the other one is 7.9. And so this 7.9 does match. So I have two sides that match, but the third ones don't. And so since these two sides don't match, these triangles are not congruent. Two pair of corresponding sides isn't enough. We need to have all the sides be able to pair up and all the angles. So in this case, because I only have two sides, these two triangles are not congruent. So here, example 2, it's asking us to find the value of the variable. So we're going to be asking in this example, what's the value of, it looks like the variable that we have here is x. So in the end, we would like to know, what does x equal? That results in congruent triangles. So in order for us to have congruent triangles, we have to have all corresponding sides and all corresponding angle pairs have to be the same. I notice right away that 5x plus 30 is a part of, with this degree symbol, it's going to be an angle. Now, there's 180 degrees in a triangle, and I notice that this 55 matches up with a 55 right there, and this 45 matches up with this 45 right there. So whatever this angle is must be the same as 5x plus 30. So if I take the two angles that I know, 45 and 55, and I add those up, I'm going to get 100 degrees. Well, I know there's 180 degrees in a triangle, so angle L, the measure of angle L is 80 degrees, because 100 plus 80 is 180. Well, that means that angle P also has to be 80 degrees, and the equation we're going to write now is going to be 5x plus 30 equals 80. And when I take and I solve that, it's going to be the next step, 5x is 50, so x is going to be 10. And so if x is 10, then the triangles will be congruent. Here's the second example about finding a variable value that would make these triangles congruent. And you can see that we don't have degrees, but I have angle little arc tick marks. So angle D is the same as angle A because there's one tick mark or one little arc, and angle C has a couple of them, and so does F. So C and F are the same. And B has 3, and so does E. And you notice that 2y plus 20 millimeters is in between D and E. And there's my variable, so we would like to know at the end of this problem, what's the value of y? And this value, 2y plus 20, is in between D and E, and D has one tick mark, just like A does, and E has 3, just like B does. So 2y plus 20 is in the same place as that side right there. And so then we'll go ahead and just write the equation that says 2y plus 20 must be the same as 36, because all pairs of corresponding sides have to be congruent. And so this right here has to be worth 36 millimeters if these triangles are going to be congruent. Plus you already have a 50 there and a 50 there, and then the other two sides are 30. So if I take away 20 on both sides, 2y is 16, and therefore y is going to give me a value of 8. So if the two triangles are congruent, y has to be worth 8. I want to take a moment and address this question because we don't actually have a figure, but we have some descriptions here. And it really relies on us remembering that every triangle has 180 degrees. So if I take all the angles and I add them up, I should get 180 degrees for any triangle. And this one is about two triangles, QRS. So I'm just going to write QRS over here. And then this other one is a triangle TUV. So this problem is probably singing the alphabet song. And QRS has two angles given to me. One of them is 18 and one of them is 84. And we need to find the third angle, and the way we do that is we just add these two up, and we're going to subtract that from 180, and we're going to get 180 take away 102 is going to give me 78 degrees. So the third angle in this triangle is 78 degrees, and that way all three of these will add up to 180. So 78, 18, and 84. Those are the three angles of QRS. And TUV has 18 and 76. Made a little writing error there, 76. I can already tell right away that these two triangles aren't going to be the same. 18 is going to match with this 18, and that's fine. These right here are going to be a match, but nothing pairs up with 76. And so this isn't going to work out. 18 plus 76, if I add that up, is going to give me 94 degrees. And when I take 180 and I subtract 94, if I want to find the other missing number, is 86. And so the third angle of this particular triangle is 86. And you'll notice that these two, even though they're close, they are not the same. So there's not corresponding pairs of angles. So these triangles are not congruent. And the reason is the corresponding angles aren't matching. I want to address one last question. Seems like we always have to go over this in class. And so I'm hoping with maybe a little bit of hints and cues, you'll be able to come up with a solution and an explanation for this problem on your own. And so the first thing that we want to take a look at is the fact that I've got this shape, and Kenny has a science project and he's trying to decide whether honeybees like one color over another. So we can imagine if these are petals on a flower, that each one of them will be a different color. So he's making a display and he's got a flower with 8 petals from paper in different colors. And each flower is, each petal is going to be a triangle. And so we're going to make the assumption that this triangle, all these triangles are the same, because if we want to test whether a bee likes color, we don't want to make the flowers a different size. So they're all going to be the same size. And if this little angle here is X, that's really coming from this X, that angle right there is X. And then both of these little guys here are the rest of that triangle, and each of those is Y. So this is X and this is X, and each one of these angles is X. And I want you to think back to how many degrees are in a whole circle. A whole circle has 360 degrees, and that circle right now is made up of 8 angles, because there's an angle right here. There's 1, 2, 3, 4, 5, 6, 7, and 8. And if you take 360 and you divide it by 8, you get 45. which means every one of these angles here is 45 degrees. And so if I take a look at the drawing, if that little, these are called central angles. And if this x, this central angle is 45, and these two angles down here, this is an isosceles triangle, which means the base angles are also the same. These two are the same, and if you take 180 and you subtract 45, that'll tell me how many degrees are left in the rest of the triangle. And it's 135 degrees, but it's split among those two angles. So if I divide that by 2, that'll tell me how many degrees each of those base angles are, because these two have to be the same. So if I divide by 2, that's going to allow me to find y. I'll let you come up with your own explanation of how you found x and y, but this will help you out. So we already know the value of x, and you can do some simple division there to figure out the value of each of these angles, which is a measure of y degrees.